Hello and welcome to Unit 8 Day 1 Notes. This unit is going to be about similarity and what it means to have similar figures and how we can use features of similar figures to solve for missing sides. Alright, so starting here on the beginning of Day 1, the definition of similar figures. Two figures are similar if one is a scale drawing of the other. So last unit was all about scale drawings. So really we've been talking about similarity for already a unit. Therefore, we know that corresponding angles of similar figures would have to be congruent, and corresponding sides of our similar figures would then be in proportion. So the same rules from last unit apply to this unit. Now, rather than saying the triangles are scale figures of each other, even though that's true, we'll be able to say the triangles or the figures are similar, and our little note is a little similar symbol that looks like the top of the congruence symbol. So it's just a little squiggly. So for example, if I give you two similar triangles, which you actually see down below, these are similar, then it must be true that angle A is congruent to angle D, because in that order those come first. Angle B would be congruent to angle E, and angle C would be congruent to angle F. So those are all the corresponding angles. Now, I'm going to mark that in the picture down below. So A is congruent to D, B is congruent to E, and C is congruent to angle F. Now, it's also going to be true that the corresponding sides are in proportion. So, for example, let's start with AB, which is the first two letters, and DE. So in my figure, that's between the single arc and the double arc, single arc and double arc. The next two would be BC and EF. So BC, EF. And then finally, from the letters on the outside, AC would correspond to DF. So filling in those blanks over here, I have AB is to DE, as BC is to EF, as AC is to DF. So everything in the top came from the bigger triangle here, everything in the bottom came from the smaller triangle. All right, so describe in words a transformation that maps ABC onto DEF. Use proper notation in words. Well, obviously there must be a dilation happening, which is what we discussed last unit with our scale drawings. So if I draw a straight line for B through E, and then I'll do the same thing for C through F. My little cursor thingy's in the way. Hold on a second. Oops. Okay, we can see they're intersecting right there at 1, 5. Mine's a little bit off because of my computer, but that's our center. So that's our center of dilation. Again, at the coordinate 1, 5. Now let's pay attention to our scale factor. So we know that 1, 2, 3, 4 units go this way, 1, 2 go this way, so those are two corresponding sides. It said ABC onto DEF, so that means that ABC is your pre-image, DEF is your image, and we know from last unit our scale factor is image over pre-image, so 2 over 4, which reduces to 1/2. All right, so writing it out in notation, I know that we dilated the triangle about the center 1, 5 with a scale factor of 1/2. Now, if you accidentally wrote 2, you should check yourself because obviously it got smaller, not bigger. Now, if you're ever in doubt about how to say it, on like an exam and it just says describe what happens and it's giving you options, I usually say when in doubt, write it out. So this is why we're practicing it twice. So this is our notation. In words, we'll write out dilate about center 1.5 with a scale factor of 1/2. All right, so everything I've mentioned up until this point is all review from last unit. Now, why does this transformation create similar figures? Or why is triangle ADE then similar to triangle ABC? Oops, it says ADE, that's supposed to be DEF. I'm gonna fix that typo. Okay, so they are similar because a dilation preserves angle measure, and if all the angles are the same, then the triangles must be similar. All right, so on the next page, we're going to practice some similar triangle applications. The first being how to solve proportions. So cross products property of proportions. So in a proportion, we know A over B equals C over D. Now B and C, which are across from each other this way, are known as the means. A and D, which go this way, are known as the extremes. Now, I'm honestly never going to tell you that you have to know which ones are which, but that's technically what they're called, means and extremes. And that's really because if you write the ratio like this, I'll do it down below, A is to B as C is to D, means are the ones in the middle. And the extremes are the ones on the outside. So again, that's why A and D are the extremes and B and C are the means, but again, you just need to know basically that you can multiply them. So we know that then A times D equals B times C because in a proportion, the product of the means is equal to the product of the extremes. And this, my friends, is going to be an important theorem that we will use throughout this unit. All right, so starting with our first figure here, I have triangle ABC similar to triangle EDC. Write proportions to solve for X and Y. Make sure corresponding sides match in your proportion. Okay, so when I'm told that triangles are similar, first thing I point out is that AB corresponds to ED. So I'm actually going to mark that in my picture. And you can use different colored highlighters or label your sides differently. I'm going to use highlighters here. So AB corresponds to ED. So those are like a matching set. Then I know that AC maps to ED, or EC, excuse me. So AC, I just picked the outside ones, corresponds to EC. And then obviously by default, then these must correspond. A nice and colorful picture. All right, so let's say we want to solve for X first. I see that X corresponds to 16.5. So I'm going to write that down first. And then I just need to use some other information to solve. So I need something that matches up. So like if I go back to the smaller triangle of ABC, I know 4 corresponds to 12. All right, so then again, this is small triangle to big triangle. Everything matches up here. So if I cross multiply, this is 12x equals 66. So x equals 5.5. Okay, I'm just going quickly through the algebra. I know you can multiply and divide. Now, in order to solve for y corresponds to 3.14. And then, okay, notice I started in the big triangle. Let's start in the big triangle again. Let's use the 12 corresponds to the 4. So big triangle to small triangle, big triangle to small triangle. From there, I can cross multiply to solve. So I get 4y equals, whatever this is. What is 12 times 3.4? Pull up my calculator. Gotta make it smaller. There we go. All right, 12 times 3.14. Oh my goodness. All right, so 37.68. All right, I'm going to take that. I'm going to divide it by 4, and I get 9.42. And there you go. Okay, next. Triangle ABC, which is this small triangle, is similar to ADE, which is this big triangle. Okay, so small triangle versus big triangle. So again, AB will correspond to AD. So just like so. AC will correspond to AD. And then lastly, it would make sense that these sides correspond. Now for something like this, you might want to draw the picture separately. So like here's my small triangle, which has the 3, the 2, and the x. Here's my big triangle, which along the side here, 6 plus 3 is 9. 2 plus y is y plus 2. And then this base here is going to be a 12. Okay, I'll add some color again. Those correspond, these correspond, and these correspond. Okay, now from there, I just need to solve for x and y. So let's start with x. X corresponds to 12, as 3 and 9 would be a good match for the other side. So that gives me what? 36 equals 9x, so x equals 4. Now, in order to solve for y, okay, y plus 2 corresponds to 2. So I went big triangle to small triangle, as 9 corresponds to 3. All right, so when I cross multiply, I get 18 equals 3y plus 6. So that means 12 equals 3y. So y ends up equaling 6. I meant 4. 12 divided by 3 is 4. So y equals 4. And there you go. Now, something I want to mention here as well before I go to the next page. With similar figures, that means all the corresponding angles are congruent. So technically, I know that this angle is congruent to that angle. They actually told me that. And these angles would be congruent as well. All the information is on the sides, so based on what we know from last unit, I could actually use triangle side splitter to solve for y. I could have done 3 is to 6 as 2 is to y. Let's see. That would give me 12 equals 3y, and there you go, y equals 4 again. Okay, so there's a couple options there. So big triangle versus small triangle, or technically triangle side splitter. I couldn't use triangle side splitter to solve for x though, so just keep that in mind. That had to be big triangle versus small triangle. All right, so the next and last page. All right, I would encourage you to pause this video and see if you can solve as well for this, for number 3. It wants FE and FL, so just for consistency, let's say x is equal to FE and y is equal to FL. Okay, again, I'm going to say pause the video and see if you can solve for x and y yourself, and then I'll reveal it. All right, so you guys should have gotten x equals 10 and y equals 4.8. So I colored my picture to help me see the correspondence. So I could see x corresponded to 4. I saw then that 15 corresponded to 6 and set up a proportion that way. For y, I did y is to 12 as 6 is to 15, and again, use that product, that cross product to solve. All right, number 4. At a certain time of day, a 12-meter flagpole casts an 8-meter shadow. Find the height h of the tree that uses the length 15 meters of the tree's shadow. Note, the triangles formed in the diagram are similar. Now, whenever we talk about heights of trees, we're assuming then that these are perpendicular. So that's where the right angles are coming from. And technically, between the big triangle and the small triangle, they have a shared little angle down there. Now, in order to solve this, if the triangles are similar, we have small triangle versus big triangle. So again, I can pull those out. My small triangle has an 8 with a 12. The big triangle, keep in mind that I said the tree's shadow was 15 meters, so that's along the base there. And I don't know the height of the tree h, which they actually super teeny have labeled there for you. Okay, so I know the 12 corresponds to the h, as the 8 corresponds to the 15. Okay, and so from there, I'm going to save us some time and just say you should end up with 22.5 after solving. All right, so the very last one is a little bit tricky because I have some orientation flipped around in this. So I'm giving you that triangle XYZ, which is the big triangle, is similar to XNM. So honestly, what I'm going to do, guys, is just pull these apart. So XNM, that's 6. This is X. They're supposed to be the right angle. It doesn't quite look like it, but that's okay. Okay, big triangle is XYZ. There's the right angle. This is 16. This is 20. All right, now let's go through this correspondence again. They're saying XY is similar to, or XY corresponds to XN. So let's label that. And then if I pick the next two letters, YZ and NM, YZ, NM, and then I really don't have to label the last two because there's really no information there anyway. All right, so the hardest part here is just how do you set up your proportion? So if I start in the small triangle, I know the 6 corresponds to the 16 because those are both yellow. Okay, go back to the small triangle because that's where I started, so X corresponds to 20. So from there, we get 16x equals 120, so x equals 7.5. And there you go. So big takeaway here, guys, for similar triangles. They're really just scale drawings, which we did last unit. I've just made them a little bit harder where you have to pay attention to what side corresponds to what, because especially in this last example, I really flipped some stuff around on you. So having different color highlighters or pens or whatever is going to be helpful for you to help match who goes to who. All right, your homework is 8-1. There are final answers on the back, so you should be able to check yourself as you work. Good luck.